We are at the STP, Society of Toxicologic Pathology annual meeting, and I'm here with Erica Remaker Erlandson. Welcome, Erica.
Hi, thanks for having me.
And we're going to be talking about this poster, a multiple instance learning approach to detecting foci of cellular alteration in the liver. The trick in pathology is when you try to train a model, an AI model, to detect a specific lesion, but you don't really annotate the lesion, and that is kind of the highlight of this poster. How does the AI know how to find the lesion if you only have a weak label of telling it that it's in this slide?
Yeah, absolutely. So the main point of doing a multiple instance learning approach is that it assigns the whole slide image as a bag, and so then it's assigning instances as tiles. So instead of running the entire whole slide image and you think about the size of all those pixels and everything like that, we're really just running certain tiles to help train the algorithm, and that's going to really help not only minimize the number of annotations that we need, but also limit the size of the whole slide image as a whole.
Amazing. So this is a lot less resource-intensive approach. So can you maybe compare and contrast the classical approach of supervised learning with annotations in terms of like how much effort goes into it?
Yeah, I mean, it's really going to depend on the lesion that you're looking at, but specifically for something like foci of cellular alteration in the liver, it's a really subtle lesion, and it's an important one for pathologists to be able to recognize. So for this, we were able to do quite a few less, but in a more standard approach to something like this, I mean, we're talking at least hours, if not days worth of annotations, and able to have some success.
So the comparison is going to be, okay, you have a bunch of annotations from pathologists several hours versus you already have your data set with the labels on the slide, and it did work. You guys achieved over 80% accuracy. Do you think this is going to be the new way of training, or it's going to be a combination of both approaches, or where do you see this field going?
Yeah, I mean, I think we can definitely start to implement it more. Our hope is to continue to develop this algorithm and then also utilize it when using other organs or other lesion identification, because it was a lot faster and we were able to have such great success.
Thank you so much. If you are at STP, this is poster number P09. Come and visit. This is the beginning of the poster break. And if you are not here, we must take a picture and post it on social media. Thank you so much, Eric.
Thank you.